let us now look at another IoT application which is of interest to us, and perhaps each one of you have to work very hard to make this IoT application a grand success. Okay. And so let us make this a very vibrant module with as many inputs as possible, so that we all work towards the nation's life expectancy improvements, and therefore I am sure you know what I mean. I am talking about air quality. One of the most important and compelling IoT applications you can ever think of when you talk about air quality. Why am I talking about this? So before I started to look at this course, we were working already on air quality, and I can share some of the systems that we have tried to build in collaboration with another industry, but that is one part of the story. But in recent times, the recent Indian Express headlines, what really scared me, you can see this. It says toxic air killed 12.4 lakh Indians in 2017. I mean, it is unbelievable, right? Just because of no fault of theirs, by just breathing the air that is free for all, and somebody polluting it and we inhaling it, our life expectancy going down. It cannot be more sad than that. So therefore, can IoT solve this problem? Can IoT monitor toxic air? Can it tell you something about what is the quality of air right now? So this is the problem. The problem of air quality is not just confined to outdoor. Please note this. There is a problem of air quality indoor as well, in closed spaces as well. Think of the trains in which we travel. What is the air quality in the trains? Think of the planes in which we travel. What is the air quality of inside the plane cabin? What is the air quality? Nobody knows this, right? No airline is willing to share it. No railway board or no railway service company is ever going to reveal anything about what the quality of air that is available to passengers. Okay, so this is in travel, in transit, when you are in different modes of transport, bus, train, plane and so on. Outdoor is anyway another story, and so this is a massive problem, and unless you have cheap sensors which can give you very quick indications of what the quality of air is, this is not going to scale up. This is very similar to some of the incidences that have happened where the nuclear power stations had issues, and then you wanted to check the radiation level before going and doing any kind of repairs and service or maintenance of these nuclear power stations. So it is no different, right? Here that is a very small place, you need monitoring, you need to find out what is a safe radiation level, and therefore you will be able to enter. Okay, quite like that, air is also the same story. What is good for you is known, is already documented. How bad it is at the moment is what is the most worrisome thing. So that is the important thing you have to note. I put down the Indian Express survey in one slide, and then they show that the average life expectancy is down by 1.7 years, and 77% of people breathe highly toxic air, which gives us a very small percentage of people who are actually not breathing highly toxic air. You have to look at it the other way. And 12.4 lakh, this is lakh, okay, out of 1 crore deaths in 2017, at least that is what the paper was reporting. They want us to read this Lancet Planetary Health article, and I have actually tried to download this article. Okay, it is available on the web. You can see this is the title of the article. So this is the article of interest, it is here. The impact of air pollution on deaths, disease burden and life expectancy across the states of India in Global Burden of Diseases Study 2017. This is indeed the article which has actually been used for this newspaper article that appeared December 7th 2018 in the New Indian Express. So, you can see the annual population, essentially population weighted mean exposure to ambient particulate matter size 2.5 is 89.9 micrograms per meter cube, right, and this is for over 2/3 of the Indians. Now what is safe is the question, how much is allowed, how much is okay. You are only allowed to breathe air which has just 40 micrograms per meter cube, and you can see this is indeed a roughly more than 2 times the safe level of what the particulate matter should be. And so where is the problem and which are the states which have this serious problem is Delhi, UP, Bihar, Haryana, and which is the best state? Kerala, which has the best air quality currently in the country. Now if you go into the details of this paper, let me show you some of the salient points from this paper. But before you go into the Lancet article, I mentioned to you about Delhi, UP, Bihar and Haryana contributing to a lot of particulate matter. Those 4 states alone, the mean value is about 125 microgram per meter cube per particulate matter. So, it is a pretty large number. Whatever you say, there are different standards for measuring what is safe and what is unsafe. Now the question is, why does it come? Why does this particulate matter at all prevalent in the atmosphere, and why is it we are breathing it? It could be because of our own doing. In fact, most of it is because of our own doing. Take the household air pollution. Okay, inside the house there is pollution. We are the cause for that pollution. Why? Because the people in the kitchen use solid fuels for cooking. They may use wood, coal, charcoal, any one of them, and that really is a cause for concern, which is a primary source for particulate matter. Then if you look at the industrial setting, coal burning for thermal power essentially is another cause for concern, because whenever you burn coal, you will end up with particulate matter, and that is what is an issue. But if you do not burn coal, you will not have power to support, that is another problem. Then there are industry emissions, then there is construction activity, brick making factories, brick kilns, that is another problem. Transport vehicles, road dust, biomass burning, waste burning, agriculture stubble burning, so many causes for particulate matter. So the article actually talks about several things, how they collect data, data collection, interpretation and all that, but you can see there is a big list of sources for particulate matter. Now is it enough if you monitor them, or should you also try to understand how to control the emissions of these things in whatever little way that you can? Okay, so that is the point. Take the case of particulate matter, what can we do? How can we reduce from in our own way using IoT, what is it we can do? That is what you may have to think about. Okay, that is one part. The next issue is also, if you have seen in that chart, there was ozone in it. We gave a number for ambient air quality and that was about anywhere from 0 to 100 ppb. Where did this come about? Where is this ground level ambient ozone? It is produced when nitrogen oxides and volatile organic compounds, VOC compounds emitted by vehicles, power plants, factories and other sources react in the presence of, I will just say react in the presence of sunlight.